Okay, hello. So this is going to be 3.1a, and as always, I'm going to explain this as best as I can, and hopefully it helps. So for these first few problems, we are going to be identifying how to solve them, I guess. Depending on what the problem tells us. So you can guide yourself through with your notes. I think that these problems are pretty similar to the notes, or like the notes like really help to solve these problems. So like for number 1, we are going to multiply 3 times 2 times 1 because the three albums placed in the multi-disc stereo are going to be represented as 3 upside down I, or like 3 exclamation point. So we know that 3 exclamation point equals 3 times 2 times 1, and that equals 26. So that would be our final answer. And then for number 2, it's going to be a similar, we're going to solve it in a similar way because we have a total of 26 letters in the alphabet. And we can arrange all of those 26 letters into a bunch of different ways. So we would basically write 26 with the exclamation point, and then you would plug that into the calculator because as you can see, it gives us a really huge number and we wouldn't be able to solve it on our own. So yeah. So we're basically for number 1 and number 2, we're basically writing down the number of things that we have with the upside down I because we are arranging those same things like in a different way. Like instead of having different factors, we have those same factors, we're just like moving them around. So like for example, let's say these are 3 lipsticks. Instead of making different combinations with, like, let's say ligas, instead of making different combinations like between them, they're different colors. So like instead of making like different combinations with them like that and like that, let's say these ligas were also different. We're just moving these around like that instead of like matching them up with other things. So since for these we're just like moving the things around like that, we can just write the number with the little exclamation point. So then for number 4, we are going to be solving it like with an actual, number 3, sorry. For number 3 and like also for number 4, we're going to be solving it with an actual equation, I guess you could say, or like an actual formula. And for number 3, we are going to be using the repetition not allowed part in our notes. So like basically we have to figure out the amount of letters that we have in this word mathematics, and the total number of letters, actually not words, letters, the amount of letters that we have in this word is 11. And then we have to figure out if any letters repeat in this word. And since they do repeat, we have to count how many repeat and how many times they do repeat. So like M repeats 2 times, and then A also repeats 2 times, and then T also repeats 2 times. So these amount of times that they repeat, we're gonna write them down under the 11, and we're gonna do 2I times 2I and 2I 2I times 2I times 2I, yeah, because 3 letters repeated and each of them repeated twice. And then So sorry, we're gonna have a brief interruption.
¿Cómo? ¿Qué es esto?
Es con la Z, sí, exam. Y también este.
¿El último?
Este es Z.
Pues que todos los hago.
No, este no. Solamente este. Este y este.
2, 1, 2, 3, 4.
Sí. Okay, sorry. So yeah, so we would arrange it like that and plug it into a calculator, and it's gonna give us this huge number. Yeah. And then number 4, we are going to write the 10 on the top because we have a total of 10 questions. This is like the total number, the total amount that we have of the thing that we're trying to figure out. And then we're gonna write 4i, 3i, and then 2i, representing the number of questions that are repeated with the same outcome. So like basically, since only one answer was answered with an A, or like only one question has an answer as A, we won't include that because we would basically just like write a 1 and there's like no point. So we're gonna be including the 4 because 4 questions were answered as B. So like basically the B as an answered was repeated 4 times. So like we would write the 4 underneath with the exclamation point, and then 3 answers were repeated with the answer C, or like C was repeated in 3 answers, and then D was repeated 2 times in 2 questions. Yeah, hopefully that makes sense. So like in those 10 questions, in the list of 10 questions, B showed up 4 times, C showed up 3 times, and then D showed up 2 times, and then A only showed up 1 time. That's why we're not really including it, because we know that when we multiply something by 1, it stays like the same. So like there's no really a point to write it down. But if you want to, you can, like just to include it. So then the answer would be 12,600. And yeah, that would be our final answer. So then for number 5, we have 4 knobs, and then we can paint them 6 different kinds of color, 6 different kinds of ways. So you can use a line method like that he showed us. So like 1, 2, 3, 4 knobs, and each of them we can paint them 6 different kinds of way. So we would multiply 6 by itself 4 times, which would give us, it would basically be 6 to the power of 4, and it would be 1,296. Yeah. And then number 6, for number 6 we have 6 different colored balls, and we're gonna be pulling out 4 of them one at a time. So if the problem was telling us to pull all of them one at a time, we would basically do the same thing as we did for number 5. But since it's telling us specifically that we can only pull out 4 balls, we're gonna be using the permutation formula. So it's gonna be 6p4. So then we would solve it like the formula tells us to. Be 6i, diga 6 exclamation point, over 6 minus 4 exclamation point. And then be 6i, and then 2i. And then I'm pretty sure you can just plug it into the calculator. could solve it manually. I think maybe you could. So like if you expanded it like 6 times 5 times 4 times 3 and then 2 and then stop it right there and then just be like that and then just multiply 6 times 5 times 4 times 3 equals 360. So yeah. Okay, yeah. I was just checking my answer. So yeah, that would be our final answer. And then for number 7, we have 13 teams. And then each of them will play each other twice. And then we have to figure out how many games are scheduled. So the order in which they play each other isn't really mentioned. Like it doesn't tell us like the specifics. So we are going to be using the combination formula. So it would be 13C and then 2. So like as I said, even though technically the teams like can't really repeat each other, there's no actual order in which they're doing it. Like I don't know if that makes sense. Like I don't know if you understand why we're using the combination one instead of the P. Like hopefully you do, but if you don't, I'm trying to figure out how to explain it. Like so like let's say we had the teams in a bag and we just pulled them out like so they can like play against each other. It would be like random. Like it doesn't, the order in which they play each other like doesn't really matter, so that's why we're using the combination. If let's say there was a specific, like let's say there was 7 blue teams and then 6 blue teams, and then we had to make the opposite colors play each other. In that case, we would use the I forgot the name, but the P formula. In that case we would, because like the order in which they play each other is important. Like the blues have to play against the reds, but in this case, let's say we were making the actual schedule, like we had like 13 little like papers with the names of the teams, and they were just all mixed together in a little bag, and we would just pull out, like we pull out 2 and then they're playing against each other. We pull out another random 2 and they play against each other. So like since it would be like random like that, we would use the C. Hopefully that made sense. That helped. And if you did understand that and I just blabbed all of that, I'm sorry. But yeah, I just have to make sure, I'm helping you. So yeah. So it'd be 13. Oh, I'm sorry for saying so many times. I can't help it. So there I go again. 13, it'll be 13C2, and then we would just write it down like as the formula tells us to. So it'll be 13 exclamation point and then 13 exclamation point parentheses 13 minus 2 and then the exclamation point. So then it'll be 13 exclamation point and then 13 exclamation point and then 11 exclamation point, and then just plug it in into the calculator and it would give you the final answer. which would be, let's see, 13 exclamation point, and then over 13 exclamation point, and then times 11 exclamation point is 2 point. I'm also, wait, I'm gonna be I don't know why I forgot this word, but like I'm gonna be reducing the number basically like into 2.5. I'm going to be I don't know why I forgot the word, but like basically reducing it, like if the number next to it is a 4, I keep this as a 5. So like the whole number, the complete number would be 2.50521, and I'm just gonna shorten it to 2.5. I don't know why I forgot the word or like the name of this technique, I guess you could say. So it would be 2.5 times 10 to the power of negative 8. So moving on, for the back, number 8. Number 8, I'm pretty sure it's pretty similar to this problem that we got in the notes. So I think I'm gonna be like, this is what I'm gonna use to help myself basically. So then it says, how many ways can you order the letters from the word trees if a vowel must be at the beginning? So we have 1, 2, 3, 4, 5 letters. So since it doesn't tell us that the words cannot be like repeating, at least for number A, we could just use the line method that like he showed us. So since we have 5 letters, we would do 5 lines, and then a vowel must be at the beginning, so we have to count how many vowels we have, which is 2. So we would write the 2 at the front, and then we would write a 4, because since this little line is already taking up 1 letter, we would only have 4 letters left for the rest of the lines, and the rest of the lines can be any 4 letters. So I can just like, we're just gonna be going based like as if it was like any of these, you know. So yeah, so it'd be 2 times 4 times 3, and then times 2 times 1, which would equal to oh wait, actually before we move on, okay, no, never mind. I was gonna say that like maybe we cannot repeat this, but we can. Yeah. So then it would be 48. Yeah, so our final answer would be 48. And then for number B, it says that it must start with a consonant and end with a vowel. So we would write again the 5 little lines. And then since we have to start with a consonant, we would count our consonants, which are 3. So we would write the number 3, and then it has to end with a vowel, and we already know we have 2 vowels, so we would write a 2 at the end. So now that 2 spaces are being occupied by the letters, like each of their respective letters, we would have 3 letters left. So we would write again a 3 here, and then a 2, and then a 1, which would then equal to 3 times 3 times 2 times 1 times 2. equals 36. And then number C says that the R must be in the middle. So we would write the lines again to help us out. And it would be, since the R has to be in the middle, and the R is like a singular letter, we would write the 1 in the middle where it should go. And then we would write a 4 since we already have one letter assigned. We are left with 4 other letters. So it would be 4 and then 3 and then 2 and then 1. Which would then equal to 4 times 3 times 1 times 2 times 1, 24. Okay, so then number D and number E, they're pretty, I guess, similar. It's just that since we have 2 E's for number D, since it could be like any of those 2 E's, we would write it 2. But for number E, for the letter E, it would just be 1 because it wants exactly 1 E. So it would be 1, and then it would be 4, 3, 2, 1. And then it would be 2, 3, it would be 4, not 3. It would be 4, 4, 3, 2, 1. So like the reason I wasn't 3, or like the reason I put 3 was because I was subtracting the 2 from the 5, but then I realized that like we're only using up 1 letter. Only 1 space is actually being taken, and the other letter is still going to be used for the rest of the places. So it would be, instead of subtracting 2, we would subtract only 1 because only 1 space is being occupied. So it would be 5 minus 1, 4, and then 3, 2, 1. And then we would get our answers from the calculator. And then for number E, for F, we do the lines again. And since it was the consonants and the vowels alternated, we would start with the consonants since it's the ones we have the most of. So it would be, we have how many consonants? We have 3. I'm sorry if there's like a lot of background noise. But yeah, I have little siblings, so if they're loud, I'm sorry. So it'd be 3, and then 2 for our consonants, for our vowels, and then it would be 2 for our consonants since 1 consonant is already being used for the first place. And then it would be 1 for our vowels, and then 1 for the other consonant, for our last consonant. And then we would get our answer from the calculator. And then, so for number 9, we are going to be expanding and simplifying. Well, from 9 to number 12, we're going to be expanding and simplifying all of these problems, I guess. And we can do this, or like figure out how to do this based on the last 2 pages of our notes. So for number 9, we could follow example number 1 and example number 2 from their permutations and combination formula thing. Yeah, from here we can help ourselves using these notes. So 6p3 would be, so we would basically just solve, I guess, like number 9, 10, and then yeah, just number 9 and number 10. We would basically just be solving them. So it'd be 6 exclamation point and then 6 minus 3 inside parentheses and then the exclamation point, and then just solve it as you would, like as we should be simplifying it or like solving it. And then for number 10, it would be 8 exclamation point 8 and then 8 exclamation point and then parentheses 8 minus 6 close parentheses exclamation point, which would then be 8 exclamation point and then 8 exclamation point and then 2 exclamation point. And for number 9, it would be 6 exclamation and then 3 exclamation. And then we would solve it. And then for number 11, we would be expanding it like the last page of the notes. And something that he specified, or that like he noted, he told us to like note, is to expand the biggest. So like basically people were expanding the top, because in our examples, in our notes, that's what we were doing. We were only like expanding the top part of the problem, of the equation, of the formula. Yeah, I don't know, of the top part of the fraction basically. So they were doing that for number 11, but he told us that like it doesn't, like we are not supposed to only expand the top. Like it doesn't matter that I don't know, that we think it's the top. We're supposed to like it doesn't matter where it is. The biggest part of the fraction should always be the one that's expanded. Yeah, sorry if I confused you there, but like it doesn't matter where the biggest I don't know what to call it, the biggest expression is. If it's at the top or it's at the bottom, you should always expand it, the biggest. So in this case, since the biggest expression is on the bottom, we are going to be expanding the bottom. Like, and we're gonna be expanding it like he showed us in the examples. It's the same thing. It's just that instead of expanding the top, we're expanding the bottom. Yeah. So since we are starting with 3n plus 3 exclamation point, we are going to let me just review, because yeah, I'm still not set exactly on how to do these. So let me just review. Let me figure it out. Sorry. Just a second. Okay, so I'm pretty sure that we can just expand it by saying 3n plus 3 and then times 3n plus 2, so like that, and then 3n plus 2, and these would cancel out, and then it would be 1 over 3n plus 3. And then after we have this, I'm pretty sure this would be our final answer, but I'm not too sure. So I'll write down the actual answer, or like our actual like final answer down in like the description if you want to know. So yeah, because I'm not too sure about this one, so I'll check it and then I'll write it down if it's correct in the description. So then for number 12, we would do like the same thing. we would expand the biggest. And the only thing that's kind of tripping me from number 11 is that we have a 3 before the n. So I'm not too sure of like what we're supposed to be doing, but I'll let you guys know in the description. Yeah. And then so for number 12, this one's I guess easier because we don't have a number next to the n. So we would solve it like you showed us in the notes. So since we are expanding the biggest, it would be n minus 4 and then times n minus 5. Actually, no, minus 3. Yeah, so it's minus 4 and then minus 5. Okay, so we have an n. We have n minus 3 exclamation point at the bottom. Okay, actually, I'm a little bit confused about these two, about 11 and 12. So I'll figure it out and let you know in the description because I'm kind of confused about these. So sorry. So yeah, I'll figure it out and just try to explain it in the description. So moving on, for number 13, we would do it as, well, for these, I think maybe I saw that in the notes or something. I'm not sure. So I'm not sure if we are supposed to solve it like that. But I just basically did it like, I solved it mentally. Like, I did it in my head. So like if, for number 11, if our equation or like our formula, for our formula, the n is going to be at the top with the exclamation point. That means that n equals 8. And then if the r is going to be at the bottom being multiplied by another factor, that means that our r6 is our r, because remember that in the bottom r times whatever other number that we have in here, when added together, it's always gonna equal to the top. So like in example 2, we can see that 5 plus 2 equals 7. Even though they're being multiplied by each other, they, when added, they equal to the number we have at the top. And Mr. Elip said that like that's going to be the case like always. So I just I guess figured that our r is going to be 6. So then our formula is going to be 8c6. Yeah. And then I kind of did the same kind of thinking process for number 14. It's just that now we're dealing with a permutation, but it's almost the same thing. The n is going to be at the top, so that means that the 10 equals n. And then in the bottom, we are subtracting n by the r. So I thought to myself, 10 minus what is equal to 4. And it came out to 6. So like 10 minus 6 equals 4. So our answer would be 10p6. Yeah. So yeah, that's how I did it. And that would be it. Again, I'm sorry for not being able to explain 11 and 12, but if I figure it out, I'll write it down in the description. And yeah, I hope this helped. I hope I didn't make it more confusing. I'm sorry if I did. But hopefully I didn't. Yeah, hopefully it helps. So thank you. Bye bye.